知道吗？有几个？看一下。杨先你有看就看嘛，你没看没关系，我不会扣你分，对不对？好 ，OK 好。你有没有觉得我们在做这个雪山隧道工程是很骄傲的一件事情？你看到哪一个部分你觉得哇靠，怎么那么厉害？你觉得你在看到哪一段的时候？哪一段？崩塌的时候？哪一段？来后面的朋友来，你们觉得看到哪一段你们觉得很骄傲？按下按钮那一段是开通那一段吗？打通的那一段。好，我觉得我看到这个片子里面最骄傲的一段是什么？他们从通风竖井往下凿，先凿一根管子之后，由下往上钻，那叫什么深井工法？这个工法之后一完成，它就可以开启第三个工作面出现。工作面出现，我们现在检核一下这整个雪山工程它所发生的问题是什么？一开始它所遇到的问题是有关于地层的问题，再来遇到了当地茶农的反对，好，然后再来就是遇到水的问题，对不对？再来是遇到时间上的问题，因为它经过了这个裂断层之后，开始比较顺遂了。现在他都说了一个，他现在就时间赛跑了，所以他为了要开启新的工作面，于是他们决定从凿井，从那个通风竖井里面另外往下挖，然后呢再开启新的工作面出来，又这样多几面，这样多4面出来了。因为我们的工程总共是2条隧道，对不对？一个叫西行，西行就是从宜兰往台北往西嘛。往西边嘛，西行；一条是东行，就是从台北往这个宜兰方向叫东行。所以我们的工程是哪一个面，它在施工的时候最难？西行线最难，所以西行线里面埋了一台 TBM， 对不对？这就埋掉了，没办法。现在我们只剩一台，之前我还在那个5号，应该是坪林吧。还是坪林还是石碇的一个休息站，只有看过它的一个纪念碑等等的。我觉得那个真的是我们值得骄傲的一点。然后他后来怎么样解决那些农民的抗议？那些茶农，那个茶农他抗议是什么？他觉得会怎么样？会污染他们的那些茶就对了。最后他怎么解决？他后来找了3个通风竖井，所以有的距离很远，而且它通风竖井还有一个功能，它可以去做切换，所以可以减轻他们当地的污染。另外一个，他们针对他们这个在钻的过程当中所产生的砾石，还有水的部分，他们也另外找比较符合可以被接受的地方去倾倒，去处理这些东西。然后减轻了这些农民他们之间的一些困惑。然后刚才不是提到，在西行线的时候，我们埋了一台 TBM， 埋了一台 TBM 之后，后来他怎么解决？后来就用炸的。各位还知道我们用炸的话，一天只可以做多长的距离吗？5到10公尺而已。它 TBM 可以做什么？可以做25到50公尺，那真的差了好几倍，的时间。所以你看，全世界最大的一台在台湾出现，全世界最大的一台 TBM 埋在台湾，也是很骄傲的一件事情，对不对？重要的是这条隧道之前那时候在做的时候，找了好多个国家来看，大家说不行，最后由台湾人自己搞，好，我觉得这是一个非常非常棒的一个问题，非常棒的一件事情嘛，所以真的很令人感动。所以我看到感动那一段是，他那个从竖井下去。重新开启的工作面，所以你会发现到我们在做这个事情的时候，花费了多少人力，还有很多工程师的技术。你想想看，我怎么样由上往下钻，而且很精准的去钻到我的那个面是刚好一致的。这很厉害哦。所以这个片子，我想要告诉各位同学是什么？去思考这个片子中它发生了某些问题，它这些问题是最后怎么解决的？他里面讲到一个，他绝不会放弃， 它就是要打通。所以各位未来你在工作上的时候，面对到各式各样的困难的时候，你是不是一样也可以有这样的一个心情？不管怎么样，我就是要解决这个问题。现在很多同学，你们未来出社会之后所面对到就直接就业的问题，就业的问题一定会困扰着各位，因为你们可能不知道你想要走哪一条路。就好像我跟各位讲我的故事，我以前是个水电工，从来没想过我来教书，人生就这么曲折。所以你要培养一个什么可以看事情问题的能力，跟我如何解决问题的能力。有可能问题不是你解决的，但是你至少可以寻求某些资源来协助你解决掉那个问题。所以我们这样看影片，希望有那种感动。哇，我们台湾人很厉害。这里尤其是我们讲说客家人是应景精神，对不对？其实台湾人也是一样。遇到问题，我们从来不会觉得困难，只要你真的有心想要做这件事情的话。所以我希望透过这个片子给大家有个想法。另外，我又选了一个101，你看都是我们台湾本土的一些案例哦，你就会发现到真的台湾人是不怕死的。12.9公里，我们算13公里，13公里弄多久？13年，死了多少人？13人，都13哦。所以记得13号星期五的那一天，不要进雪山隧道。OK， 这是我开玩笑的，没有那回事哈。好，另外我再给各位看了一片哦，这一片希望刚才大家那一片睡了不少人，这一片应该不会睡太多人啦，好不好？我现在都是拿我们跟台湾有相关的一些让大家比较有感觉的啦，这个片子，大家来看看。101大楼。那个冷气可以开18度吗？这样就不会睡觉了。
The world's tallest skyscraper. 580 meters of the most high-tech engineering and construction on the planet. Mixing ancient values with cutting-edge technology. And taking the heart of Taiwan into the future. Designing and building the world's tallest skyscraper is no easy task. But even Taipei, two of the most powerful forces of nature, earthquakes and typhoons, combine to make going super tall a super challenge.
I mean, any tall building in the world is a feat of engineering.
Using world-leading engineering and construction techniques, Taipei 101 not so much conquers nature, but outsmarts it.
This is the only super tall building in the world that's designed in a seismically active zone. This has never been done before, certainly not to this scale.
The result is a man-made marvel, a unique megastructure of unprecedented size, shape and technology, built to withstand the very worst that nature can dish out.
I, for one, I'm a structural engineer. If there's going to be an earthquake in Taipei, I want to be in this building. I mean, I'll treat this above all else.
And it's not just as a superstructure where Taipei 101 pushes the boundaries.
We're not only managing a building or a city of a city. I believe we're managing a symbol and landmark of Taiwan.
Taipei 101 is a benchmark of technological brilliance and innovation. A record-breaking megastructure that defies nature and puts the small island of Taiwan firmly amongst the giants of global industry. For as long as humans have been making buildings, those buildings have been getting taller. From the Empire State Building in 1931, Sears Tower in 1974, Central Plaza Hong Kong in 1992, to the recent Petronas Towers in Kuala Lumpur. Skyscrapers are buildings that go beyond functionality. They are symbols of prosperity and power, icons of wealth and industrial might.
If you're looking at the history of skyscrapers, really begin in America. Chicago and New York are the classic cases. But in the last, let's say, 10, 15 years, Asia's really boomed with regards to the building of large structures.
In recent years, Asia has seen an explosion of mega-scale building and industry. The region now holds 8 of the world's 10 tallest buildings. And as modern construction methods and materials continue to improve, designers will continue to aim ever higher. Not because they have to, but because they can. Developer Harris Lin is one of the most powerful and successful businessmen in all of Taiwan. A member of a major construction dynasty, for him, Taipei 101 is the result of a lifelong ambition.
Since I was a boy, I have dreamt that one day I would build a great building, one which will benefit later generations for a very long time.
For Harris Lin, Taipei 101 is more than just a building. It's a statement on Taiwan, its people, and its future. A notice to the rest of the world that Taiwan has the technology, the industry, and the determination not just to join the giants of global industry, but to lead them.
There's no better way, really, of getting global attention than building these super tall buildings, particularly if it's the highest in the world.
Initially earmarked as the centerpiece for the growing and glitzy Zhongshan district known as Taipei's Manhattan, the primary goal for the building is to be the best, but not necessarily the tallest. Long-standing friend of Harris, architect C.P. Wang from C.Y. Lee & Associates, comes into the project in the early stages.
We started with 3 buildings, a 60-story building in the center and 2 smaller buildings that are about 20 stories for the different shareholders.
But plans quickly evolve as key investors clamor to have the building push up, not out. The planned 60 stories soon turns into 88, and with the mantle of the world's tallest a mere 13 floors away, the momentum becomes unstoppable.
We truly believed we could do it. That if we work hard, we could make a building that was visible to the entire world.
But 3 factors combine to make this project not only the tallest and most visible in the world, but also one of the most difficult to build. Taipei City is an inhospitable place to build a skyscraper. Beneath the earth, a thick layer of soft clay demands uniquely designed foundations. While above ground, the threat of earthquakes and typhoons requires a level of engineering and construction never before achieved. If Harris Lee wants to make the tallest building in the world here, his engineers and builders will have to confront the power of the earth. Design a structure flexible enough to resist an earthquake, but stiff enough to resist a typhoon. Contradictory requirements that until now have never been combined.
All these different mixtures of elements have to be blended almost superbly in order to make the building achievable.
The solution will combine 2 revolutionary systems. First, a braced megaframe joined to 8 super columns filled with a mixture of steel and concrete. And a tuned mass damper, a giant pendulum, the weight of 10,000 people, designed to oppose the effect of wind. The combination of these 2 concepts is groundbreaking.
I am very proud of it, and as architect, you don't get a lot of opportunity to work on something of this magnitude.
Construction will take 6 years, 2,000 workers at any one time, and 700,000 tons of the most advanced steel and concrete ever made.
These cost more than the national GDP of some countries.
Yet despite all the investment, ingenuity, and determination of humankind, the forces of nature can strike at any time, whether you're ready or not. Taipei 101 will be built to withstand earthquakes and typhoons, but it also needs to withstand the test of time. To be a true landmark, it must look unique. Its appearance mixes traditional Chinese icons, bamboo for strength and resilience, a pagoda for serenity, the perfect form of an open flower, and the luck and prosperity associated with the number 8.
We tried very hard to do something that we hope can represent the city, the island, as well as our culture.
The result is this: 508 meters tall, 101 floors from ground level. A building that looks completely unique, but soon proves challenging to build. Every major skyscraper in the world is a trade-off between what will look good and what will stand out.
For a tall building this height, you cannot escape in the practical matters. It has to work.
Taipei 101 will be the tallest skyscraper on Earth. And the forces on a building of this scale are truly immense. Gravity forces it down, while wind pushes it sideways. Existence is a tenuous balance between being strong enough to stay up, but not so heavy as to cause collapse. Most skyscrapers have exterior walls that are either straight up and down or sloping in. But Taipei 101's unique shape sees much of its exterior surface sloping out. Here at Evergreen Consulting, engineer Shaw Shi oversees plans that will translate Taipei 101's unique exterior into one of the strongest, lightest, and most resilient interiors ever made.
The shape of Taipei 101 is more complicated than regular tall buildings, because simple and straight lines will be easier to work with.
Aesthetically, Taipei 101 is broken into sections resembling a stem of bamboo. But similarities with this fast-growing superplant don't end here. Just like bamboo, the distinct structural sections of 101 strengthen and support the whole building. Each section operates as an independent unit, transferring the building's massive weight away from the outside of the building and into the middle. The result is a stronger, lighter, and more flexible tower. For C.P. Wayne, this sort of lateral problem solving has been integral to the success of the project. Their aim is not just to be the highest, but to be their innovative best.
Let me put it this way, it's not like the Wright brothers when they invented the airplane. You know, today a lot of people knows how to build airplanes, but it's how good it is matters.
The design of Taipei 101 requires unique engineering to facilitate a unique shape. But the next challenge facing designers pushes this engineering to the limit. How to make the tallest building in the world stand up against two of the mightiest forces of nature in one of the most hazard-prone cities on Earth. Every year, the people and buildings of Taipei are under attack from two of nature's most primal and unstoppable phenomena.
When you put a tall building on an old secondary earthquake fault line, which runs nearby here, and in a place where you get significant typhoons, that just has major challenges.
The problem is that to resist wind, a building must be stiff. But to survive an earthquake, it must be flexible. Taipei 101 will have to be both.
This is the only super tall building in the world that's designed in a seismically active zone. This is really pushing engineering and construction boundaries right to the limit.
The island of Taiwan sits at the junction of two tectonic faults, where vast plates of the Earth's crust grind together, causing earthquakes. The entire island is unstable. 3 smaller faults run directly under Taipei itself, causing hundreds of earthquakes every year. The effect of an earthquake on a giant skyscraper can be catastrophic. the entire building is shaken to its foundation as intense waves of energy from the Earth are transferred to every inch of the building structure. To withstand these shocks, the building needs to be flexible so it can move with a quake and not against it. If it's too stiff or brittle, it can break. Superficial damage like broken windows or walls can be repaired. But any damage to the internal steel framework of the building can be a disaster. As the tallest building in the world, Taipei 101 must be engineered to withstand major earthquakes. But just how major is something of a mystery. Geologist Dunstan Chen is one of the scientists charged with finding out the details.
This is when we make a first design, okay, we have to consider this fault. We know there's a fault somewhere here, but we don't know exactly where it is.
An investigation is launched involving some of Taiwan's leading geologists to find out where the fault is and how far it is from the Taipei 101 site. They need to establish if it's active and how they should deal with it. The results shock everyone.
Then we field number 4. Okay, we encountered the fault. And this fault actually, the gauge was around 10 meters thick. It's a huge one.
In most earthquakes, the closer the building is to a fault, the worse the impact. The fault found by Dunstan and his colleagues is not only huge, it's close. Only 200 meters away from the 101 construction site. 101 must be prepared to face the most extreme earthquake shocks imaginable. Here at the Necri facility, scientists use a multi-dimensional shape table to simulate a variety of different earthquake scenarios. Scale models of different structural configurations are tested, and the information gained helps to design buildings that are better able to withstand the devastating impact of earthquakes. An earthquake shock delivers brutal, vertical, horizontal, and twisting strain on a building. Every joint of every structural element is strained, and if there is one weak link, the whole lot can go. To keep 101 standing in a major earthquake, engineers develop a complex internal megastructure. The central core of the building is connected to 8 incredibly strong supercolumns by a network of horizontal outrigger trusses. The supercolumns act like a giant flexible spine, enabling the building to flex and move if it needs to, but not break. Although the idea of supercolumns has been used in other buildings before, the size of 101 takes this engineering to an entirely new level. But the threat of earthquakes isn't the only natural force that builders of Taipei 101 have to worry about. Every summer, unstable equatorial air off the coast of Taiwan generates vicious typhoons that lash Taipei. These intense tropical storms, with winds of up to 200 kilometers per hour, can literally blow a building to pieces. But it's not just strong winds that designers at 101 have to worry about. The surface area of a skyscraper is so huge that even a small breeze can still have a major effect. As wind hits a building, it impacts in 2 ways. First, the exposed face of the building can be pushed by the wind like a giant invisible hand. But under certain conditions, the wind can generate pulsing vortexes on opposing sides of the structure. The vortexes begin to oscillate, exerting small but consistent pushes on alternating sides of the building, eventually causing it to sway. Like a child pumping their legs on a swing, each gust of wind adds energy. This swaying can be so severe that occupants of high-rise buildings can experience motion sickness. Normally, engineers can accommodate this problem by making the internal structure of the building stiff and rigid. engineers of 101 design a building that is both stiff and flexible at the same time. For the project to go ahead, they have to. Taipei 101 is so massive that finding ways to minimize the effects of wind is a vital element of its design. Engineers and scientists begin with the building's exterior. They find that by using re-entering or saw-toothed corners, the flow of wind around the building is drastically reduced.
The results of wind tunnel testing, the re-entering corners help to reduce the dynamic wind response by 30 to 40%.
Saw-toothed corners on a building hinder the formation and impact of the small wind vortexes that can cause it to sway. But just like the pumping of a child's legs on a swing, where each push adds energy to the last, even when the effective wind on a skyscraper is reduced, energy will continue to gather unless it's removed. It's not the size of the push that matters, it's the repetition. If engineers can find a way of cancelling this accumulation of energy, then the building's contradictory requirements of strength and flexibility will finally be met.
Usually, a lot of the tall buildings use so-called computer-controlled mass to do that function. In our case, I think our very smart engineers come up with this passive two-mass anchor.
The passive damper on 101 uses a huge weight hanging from an upper floor to counter the effective wind. As Taipei 101 sways in one direction, the tuned mass damper swings in the other, cancelling the buildup of energy and reducing the building's motion. Engineers at Taipei 101 have made the impossible possible, designing a building that is stiff enough to survive a typhoon, yet flexible enough to survive an earthquake. But although these ideas seem to work on paper, they are yet to be proven in practice. 101 is going to need a lot more than just new design to combat nature. It's going to need entirely new materials and construction methods as well. Taipei 101's unique megastructure and wind damper will make the building resist the impact of earthquakes and violent storms. But all of this engineering means nothing unless the giant building has a solid foundation on which to sit. Finding solid ground in Taipei is a lot harder than it sounds. Over hundreds of thousands of years, changing sea levels have filled the Taipei Basin with layers of soft, unstable silt and clay. In order for the tallest building in the world to remain standing, its foundations must penetrate through this layer, sometimes 60 meters thick, to find the solid bedrock below. Geotechnical engineers spend 8 months collecting core samples to analyze the soil on the building site. They find 3 distinct layers of soft sediment before finally reaching solid ground. This information helps designers to develop detailed plans for 101's foundation structure. Preparing the foundations takes 15 months and removes 700,000 tons of earth from the site. The foundation of a skyscraper is one of its most vital structural elements. It must distribute the building's enormous weight evenly below ground, at the same time creating a super strong base for the towering megastructure above.
That's the key point for the whole building, that the building can stand up into the sky.
To compensate for the inherently unstable ground of Taipei, 101's foundation is designed to literally pin the building to the deep layer of bedrock below. A 23,000 cubic meter concrete slab sits on top of a complex system of 382 reinforced concrete piles.